Hello, ladies and gentlemen. Welcome back. We are on chapter 9.2, dealing with sample proportions. I just want to remind you, ladies and gentlemen, make sure you are reading the chapter and make sure that you look at those other videos that I have on Schoology from the College Board for each section. Those are highly recommended. Now, this first example, I've used this example a lot over the years. And I know that it's a little controversial, but it's right out of the book and it's the one that I'm going to go with. All right, so forgive me. Here we go. What proportion of U.S. teens know that 1492 is the year in which Columbus discovered America? A Gallup poll found that 210 out of a random sample of 501 American teens aged 13 to 17 knew this historically important date. Okay, the sample proportion looks like this. Notice that we're using P for proportion, and we got that little hat on it, P hat. Okay, so that would be 210 out of the 501, which is 0.42. Okay, so that is the sample proportion is 0.42 is the statistic that we use to gain information about the unknown population parameter P. Okay, remember parameter is the entire population. So P, just the P stands for the entire population. Proportion, P hat stands for the sample proportion. I'll go over that again on another slide here. Because another random sample of 501 teens would likely result in a different estimate. Remember, each sample, we saw that in chapter 9.1, each sample is going to produce a different outcome, right? A different estimate. We can only say that about 42% of all U.S. teenagers know that Columbus discovered America in 1492. All right? Little comic here. Let's see. I don't get it. There isn't a Cleveland Day. There isn't an Akron Day. As far as I know, there isn't a Cincinnati Day. So why is there a Columbus Day? The world has many mysteries. All right, just kind of a silly cartoon right out of our book, folks. All right, so P hat, proportions. Okay, this chapter 9 is dealing just with proportions, not averages, not means, proportions. So P hat is the count of success in a sample over the size of the sample. Okay, the estimate for the population proportion, mu P hat equals P. Again, P is for the population. The standard deviation, ladies and gentlemen, the standard deviation of P hat equals the square root of P times 1 minus P divided by N. Now, this is on our formula chart, ladies and gentlemen. Let me pull back the formula chart. Hopefully you have that printed off somewhere. If not, I have it attached right above this video again. Okay, right here, right underneath the binomial distribution, ladies and gentlemen, you can see those two things for the proportion. Mu sub P hat is an estimate of the population proportion. Standard deviation, P hat equals the square root of P times 1 minus P. So P times its complement divided by N, and then the square root of that. All right, so that's where you can see that on the formula chart, ladies and gentlemen. All right, getting back to this. All right, I already showed you the formula chart. You can also find this on page 582 in your book. The mean of the sampling distribution of P hat is, again, this is the symbol that we use for that. The standard deviation of the sample distribution P hat is. Okay, moving on. Now, rule of thumbs. You've got to memorize these. You're going to have them memorized for the AP test. Okay? Use the recipe for the standard deviation P hat only when the population is at least 10 times as large as the sample. So that means N, again, N is the population size. And the lowercase n is your sample. So your population needs to be at least 10 times larger. than your sample. Okay? Your population, yeah, I said that right. All right. Now, what I want you to remember back from chapter 2, remember the z-score. Okay, remember the z-score. Z equals x bar minus mu divided by the standard deviation. That's when we're standardizing those values. Now, let me go back to the formula chart here for a second to point this out. Okay, this right here, ladies and gentlemen, this right here is your standardized statistic. Okay, notice that on the formula chart, they put it in words. I don't know if I talked about that very much or not. They just put statistic minus parameter divided by the standard deviation of statistic. The reason they use words instead of the symbols that I have in blue here, folks, is because that standardized test statistic changes depending on the problem. It is now going to evolve. Okay, we're going to be doing how that evolves in all these chapters until the end. Okay, so how does that evolve? Let's go back. It now looks like this, folks. Instead of z equals x minus mu divided by the standard deviation, okay, when we're dealing with proportions, that's what it looks like. Z equals p hat, the sample proportion, minus p, the population proportion, divided by the square root of p times its complement divided by n. Notice, ladies and gentlemen, that the standard deviation is p, not p hat. Important detail. Okay? Mistakes are often made because they use the wrong, so make note. It's p, not p hat in the standard deviation. All right? So when I go back to the formula chart, ladies and gentlemen, I notice, look, right here, standard deviation of statistic, sample proportion. Okay, so they give you this on the formula chart, and then you got to remember that that goes in the spot of the standard deviation when it's a proportion. And the statistic is p hat minus p. Okay, those are details you have to remember, but if you go back to this part right here, okay, it's showing you some of that information. All right, understanding how to read your formula chart is also very important. All right, so ladies and gentlemen, that was it for that part. Now let's look at applying this to an example. The Gallup poll asked a probability sample of 1,785 adults whether they attend church, or that should be or, synagogue during the past week. So suppose that 40% of the adult population did attend. 40% of the adult population did attend. We would like to know the probability that a simple random sample of 1785 would come within plus or minus 3 percentage points of the true value. All right, well, ladies and gentlemen, so what we need to do first of all is, so let's look at A. If p hat is the proportion of the sample who did attend church or synagogue, what is the mean p hat? What is the standard deviation? Okay, so this first one is just writing this out. So we say mu p hat equals equals p, right? Which in this case is 0.40. Change your 40% to a decimal. Our standard deviation, okay, is going to equal the square root of 4.4, sorry, hold on here, Mr. Ellering. Okay, 0.4 times, now folks, 1 minus 0.4 is 0.6. Okay, just put its complement in there. Those two always got to add up to 1, remember. Divided by the 1,725. Okay, so we're gonna, if we type that in, I'm not gonna take time to type that in, folks, because I know you can do it. Okay, well, let me demonstrate really quick so that we don't make a mistake. So when you do this, folks, the square root, just type it like this: 0.4 times 0.6, notice I did not use parentheses, divide by 1,785. Notice I just typed the whole thing in, it's all underneath the square root. You do not have to use parentheses when you do that. Just type that whole thing in like that. All right, so our standard deviation is approximately 0.0116. And again, I'm going to go 4 digits on that. Remember, rounding further is better than rounding too soon. All right, now explain why you can use the formula for the standard deviation p hat in this setting. Okay, rule of thumb number 1. So if you remember, rule of thumb number 1 says the population size must be at least 10 times the sample size, right? So if I take n, if I take the 10 times the 1,785, okay, that's going to give me, let's see, 17,850, right? Okay, so I'm going to type this instead of writing this, so let me get this up. All right, so here we go, folks. So we can use, okay, I guess I need to write this next part because I can't really type it. So we can use the square root of p times 1 minus p divided by n. All right, let me continue typing. We can use that for the standard deviation because the population of people who attend church or synagogue, let me move this down a little bit. Actually, let me make this smaller, ladies and gentlemen. My apologies. That'll give you time to get caught up. Guess we don't need it quite that large. Let's go with that. There we go. That means I got to move this over a little bit. Yeah, right there. That's good enough. All right, so, man, let me tell you, sometimes things just don't work out the way you want to. There we go. And then I didn't spell synagogue right. Let me get synagogue spelled correctly here. G-O-G-U-E. All right, there we go. Who attend church or synagogue is much, okay, think about this, folks. Everyone who attends church or synagogue, is that more than 17,850 people? Yeah, okay. Okay, hopefully you just think about it and go, oh yeah, there's way more that attend. So much larger than 17,850. Okay, there's way more people that attend church and synagogue than that. All right, moving on. So that explains why we can use the proportion, or why we can use the standard deviation in this setting. Okay, C. Check that you can use the normal approximation for the distribution p hat, rule of thumb number 2. Okay, rule of thumb number 2. Which I didn't show you earlier, is this. We will use the normal approximation if the sampling distribution of p hat for the value of n and p satisfies this. So what this is saying, ladies and gentlemen, is if you take the sample size times the proportion, it's got to be greater than or equal to 10. take the sample size times its complement, it's got to be greater than or equal to 10. Now, I'm going to warn you right now. This will evolve over time. I can't even spell the word evolves. So I'll do this. This will change later. I know that seems really confusing. Well, we learn these rule of thumbs, but then it's going to change. Yeah, because there are certain situations where the rule of thumb gets slightly changed. Statistics is full of details, believe me. All right. So, but we won't worry about that right now. So rule of thumb number 2 just is saying that if those two things are true, then we can use the normal approximation. That means we can use the z-score. Okay, that means we can use the z-score. All right, let's get back to that problem. So here we go. So that means if I take so let me write n times p has to be greater than or equal to 10, and n times its complement must be greater than or equal to 10. So if I take the 1,785 times the, let's see, what did we get? 0.4. All right. And if I solve that, I'm going to get 714, which is greater than or equal to 10. And then if I take the 1,785 times the complement, okay, well, obviously that's going to be greater than 10. That's 1,071, which is greater than or equal to 10. So we will actually state, folks, after we show that they are greater than or equal to 10, we're going to go ahead and say we can use z equals p hat minus p divided by the square root of p times 1 minus p divided by n. Because n times p is greater than or equal to 10, and n times its complement is greater than or equal to 10. Whew! Get used to checking conditions. Again, we want evidence to show something, right? And in order to do that, we have to follow all these rules, and there's lots of conditions that we need to follow. All right, D. Find the probability that p hat takes a value between 0.37 and 0.43. Will the SRS of sample of size 1785 usually give a result within plus or minus 3 percentage points of the true population mean? Okay, ladies and gentlemen, so here, this is what we're going to write. Are you ready? Okay, notation time. We want to know the probability that, now 3 percentage points, that would be 0.37 to 0.43 above and below the 0.4, right? It's telling us that. That's what this is right here. So we're going to write we want to find the probability that 0.37, that the p hat is going to fall between those two proportions. Now, what we have to do, ladies and gentlemen, is now we have to convert to a z-score. Okay, so we got to go z equals. So we're going to do 0.37 minus 0.4 divided by the square root. Now, folks, I'm not going to, okay, hold on here. To save a little bit of work, we already found the standard deviation right here. Okay, we already found it. So I'm just going to put the 0.0116 underneath that. Okay, because I already found that in a previous step, right? Okay, and that's going to give us a z-score of negative 2.59. Remember, subtract the top first, get that answer, and then divide by the denominator. The other one Okay, we're going to take 0.43 minus the 0.4 divided by the 0.0116. And folks, if you really think about it, that's going to give us the positive 2.59. Now remember, z-scores, we can always round to 2 decimal places because of table A, that z's table. But I'm not going to use the table, folks. I'm going to strictly stick with the calculator. All right, so now I'm going to fill this in with negative 2.59, the positive 2.59. All right. Now, we should be drawing a picture at all times, folks. Okay, some of you didn't draw pictures on a few problems on the test, on tests, but you should always draw that picture. So that's what we're interested in, folks. Okay, so now what we can do is we don't need to write down anything. No calculator notation is needed here. So I'm going to go to the calculator. Remember how this works. We're going to go second vars. We're going to pick number 2, normal CDF. Lower bound is the negative 2.59. The upper bound is the 2.59. Leave your mean 0, your standard deviation 1, because we've standardized it already. We're going to paste that in, and whoa, 0.99. All right, so I'm going to type here again. So now we need to give our conclusion here. So what can we say? All right, we can say, ladies and gentlemen, that over 99%, it's okay to go to a percent here, over 99% of all samples, okay, go back and read the problem so you can get this connection, of details of size 1,785 will produce a sample proportion within now normally I would just put a plus and minus sign here, but I'm going to do this, within plus or minus 0.03 of the true population proportion. Okay, pause and think about this. If I draw samples of 1,785, 99% of all of those samples will be within 3 percentage points of the true population proportion. Okay, let me say that again. Think about it. Pause, rewind if you need to. Okay, 99% of the samples that I would draw of 1,785 will produce a proportion that is within 3 percentage points of the true population proportion. Okay, grasp that. That's something that can be tough at times, but try to grasp that. All right, let's look at another one really quick. Choose a sample size, a simple random sample of size n from a large population with a population proportion p having some characteristic of interest. Let p hat be the proportion of sample having that characteristic. All right, what is the mean of the sample proportion? All right, folks, it's simply the symbol. Oh, let me get my pen back. It's simply the symbol. There's no numbers, so that's what it is. Standard deviation. Okay, under what conditions will the formula for the standard deviation of p hat be reasonably accurate? All right, that would be rule of thumb number 1. The population size is at least 10 times the sample size. The sample distribution p hat is approximately normal when the sample size n is large. What conditions need to be met in order to use the normal approximation for the sampling distribution? Okay, that's rule of thumb number 2, which says okay, the sample size times the proportion must be greater than or equal to 10, and the sample size times the complement must be greater than or equal to 10. That is what we have to satisfy in order to use the normal approximation. All right, number 5. According to the government data, 22% of American children under the age of 6 live in households with incomes less than the official poverty level. A study of learning in early childhood chooses a simple random sample of 300. Okay, what is the probability that more than 20% of the sample are from poverty households? Remember to check that you can use the normal approximation. All right, folks. So if I take, let's see, so 22%, that's our P, that's, yeah. So let me back up here. So the N times P. Okay, if you take the N times the P, you will get 66. Okay, check the numbers. If you don't know how I got 66, figure it out. I want you to do that. And N times 1 minus its complement is going to be 234. So, rule of thumb number 2 is satisfied. All right. So we can use the normal approximation. So here we go, folks. We're going to write this out. So we're going to say, we want to know what is the probability that P hat is greater than 0.20. Remember to always change your percents to decimals. So that's what we want to know. So what we're going to need to now do, ladies and gentlemen, is figure out the z-score. So let me do the z-score off to the side over here. So z equals, we're going to take the 0.2 minus 0.22 divided by, okay, now the square root of 0.22 times 0.78, make sure you use P and not P hat, divided by 300. So if you do all that math, ladies and gentlemen, you're going to get a z-score of negative 0.84 if we round it to 2 decimal places. Now, if I draw a picture of this scenario, my negative 0.84, I'm going to say that's right here. And I want to know what is that area. All right, so now I'm going to go ahead. Now remember how this works with the calculator again. So the negative 0.84 is my lower bound. There is no upper bound, so I'm just going to pick a really big number. Okay, so my lower bound is the negative 0.84. My upper bound, it's infinite, but we can't use infinite here. I wish we could just put infinite there. So just pick a large value like 100, because that's there is no upper bound, so I will use 100. All right, and that's going to be 0.7995. Whoops. All right. Now, normally I would write a conclusion here, but I don't have room for it. So the question is, what is the probability that more than 20% of the sample are from poverty households? Okay, well, we would use the question to help answer it. So the probability that more than 20% of the sample proportion are from poverty households is, okay, use the question to write your conclusion. So what is the probability that more than 20% of the sample are from poverty households? Is approximately 80%, or 0.7995. You can use percent or decimal there. Okay, again, use your question when you write your sentence conclusion. Sorry, I don't have room there and I don't want to take, I'm already up to 30 minutes on this. All right, what is the probability that more than 30% of the sample are from poverty households? Okay, so now this one is more than 30%, right? So I'm going to write this out. So the probability that p hat is greater than 0.30, always use the decimal, don't use the percent. Then we're going to convert that to a z-score. Okay, ladies and gentlemen, I'm just going to go, you can go ahead and do the math on that. So you're going to end up with a z-score of 3.3, roughly 5. It rounds to 3.35. Okay, and then you end up with, when you do all of the other stuff that we did up, you get 0.0004. Ooh, that's really small. So the probability that more than 30% of the sample are from poverty households is less than 1%. Okay. All right, I'm going to go ahead. So to do that z-score, folks, it's going to be 0.3 minus the 0.22 divided by the square root of the 0.22 times the 0.78 divided by the 300. All right, I have one more. I've gone over everything, okay, but I do want to go over one more example. I would suggest continuing this video and watching me do this example, but if not, feel free. Oh, before you leave, I do want to show you this. Okay, I do have some extra notes attached to above the video. So I've got it typed out for you if you want to print it off. So chapter 2, there's our normal. That's what we learned in chapter 2, right? Chapter 9.2 is our proportions that we're talking about now. Here's rule of thumb number 1. Here's rule of thumb number 2. If you want to, instead of writing it out, you have that right there. Some of you probably already wrote it out. Sorry about that. But I do have that right there for you, okay, if you need it. All right, I do want to go through one more example. I would suggest sticking around or coming back and looking at this example later if you are already wore out from the first part of the notes. Here we go. An opinion poll asks, are you afraid to go outside at night within a mile of your home because of crime? Suppose that the proportion of all adults who would say yes to this question is 0.4. So that's our population, right? The proportion of all adults, P equals 0.4. Use the partial table of random digits below to simulate the result of a simple random sample of 20 adults. Be sure to explain clearly which digits you use to represent each of yes and no. Write directly on or above the table so that I can follow the results of your simulation. What proportion of your 20 respondents were yes? All right, ladies and gentlemen, so this is what I did, okay? Yes, that's going to be, I let that be the digits 1, 2, 3, 4. No, that's the digits 0, 5, 6, 7, 8, 9. Okay, that's how I set this up. All right. So if I go through this now, ladies and gentlemen, okay, I'm not going to do this whole thing. That would take too long. So I would do this. This is a no, no, yes, yes, no. So I got 2 people there. Okay, yes, no, yes, 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 4 people there. Okay, that's been 10 people, right? And I'm going to run, and I'm going to do 20 adults. All right, well, that's already been 10 adults, right? Okay, So what I end up here with, ladies and gentlemen, is 1, 2, 3, 4, 5, 6, 7. I end up, well, let me just finish it here. So this is yes, no, no, yes, no, no, yes, no, no, no. So let's see here. Did I miss one? 1, 2. Oh, 0 is a no. My fault. My fault. 0 is a no. That one's a no. So 3 there, 2 here, and 1 here. And let's see. So in this situation, I got 5, 6, 7, 8, right? I got 8 out of 20. And then I could run this simulation many times. Remember, if you run it again, you're not going to necessarily get that same result, and so on. All right, so that was just running through that. So if I repeated it, so if I repeat it on this line, folks, I'm going to get 6 out of 20. If I repeat it on this line, ladies and gentlemen, I'm going to get 9 out of 20. If you don't believe me, go and look. If I do it again here, I'm going to get 9 out of 20 again. And if I do another 20 people here, I'm going to get 9 out of 20. Okay, so I repeated it with, and I have it now. I have a total of 5 samples, right? My first sample is 8 out of 20. That's my first sample. So if I add all of that up, ladies and gentlemen, I end up with 41 out of 100, which is 0.41. Wow. So is it close to P? Yeah, the simulation, yes, it is. It's very close to P. Okay. Again, I didn't show the details, but that's the results when I run the simulation. All right, number 3, the sample distribution p hat is the distribution of p hat from all possible simple random samples of size 20 from this population. What is the mean of this distribution? Okay, it's the symbols, folks. Not 0.41, that's our sample, okay? It's asking about the mean of this distribution, which is all possible, okay? And then the standard, and then if the population proportion is 0.5, what would be the mean of the sample distribution? Well, ladies and gentlemen, it would be 0.5. Okay, don't get blocked with the wording of things, okay? So just be aware, read carefully, and think about what's the sample proportion, what is the population proportion, what are they asking for? Lots of new symbols, not lots of new things in here. All right, if you need to, please rewatch any part of this, ask questions during class. We'll do some problems together on these sample proportions. All right, ladies and gentlemen, see you soon. Good luck.